Okay, so now we're going to go through paper 4, which is the extended theory paper for chemistry. This is IGCSE from Cambridge International Examination CIE from May-June 2016, and this is variant 1, so 0620/41. All right, let's get started.
It's time!
Question 1. Protons and neutrons and electrons are subatomic particles. A. Complete the table to show the relative mass and the relative charge of a proton, a neutron, and an electron. All right, so a proton and a neutron both have a relative mass of 1, and that's why the mass number is the number of protons plus the number of neutrons. And the electrons are almost weightless, but obviously they're not weightless. Everything has a weight, even an electron. 1/1840th of a proton or a neutron. The relative charge of a proton is +1. You can't just write plus because it is +1. The relative charge of a neutron is 0, has no charge, and the relative charge of an electron is -1. All right. B. Bromine has 2 isotopes, and define the term isotopes. So isotopes are atoms that are of the same element, but they have different numbers of neutrons. Isotopes are atoms of the same element with different numbers of neutrons. Okay, they have the same number of protons and different numbers of neutrons. 2. Explain why the isotopes of bromine have the same chemical properties. So the reason why they have the same chemical properties is because of the outer shell. They have the same number of electrons in the outer shell. So both have the same number of electrons in the outer shell, and chemical reactions have to do with the electrons. Okay. C. The table shows the number of protons, neutrons, and electrons in some atoms and ions. Complete the table. Okay, so first of all, we have the big number at top is the mass number. So this is the mass number, and the small number is the proton number. So if lithium has 3 for the small number, the proton number, that means it has 3 protons. If sulfur has 16 for the proton number, it has 16 protons. Now lithium is uncharged. So uncharged means it has exactly the same number of electrons. Sulfur, on the other hand, has a charge of 2-. That means it has 2 more electrons than it does protons. So it has to be 18. Now the protons plus the neutrons put together are the big number, the mass number. So 7 equals 3 plus the number of neutrons. So the number of neutrons here is 4. And 34 equals 16 plus the number of neutrons. So that means the number of neutrons here has to be 18. And finally we have to figure out what this is. So if the proton number is 19, that means we have to have the small number as 19. The big number has to be 19 plus 22, so it has to be 41. And now we have to figure out what element it is. Okay, so it said it had 19 protons. That means it has to be 19 here. It has to be potassium. Okay, and finally we have to look at the protons and electrons are the same. And so there's 1 more proton than there are electrons. That means it has to have a charge of +1. And for that you just write in a plus. That's it. Question 2. Period 3 contains the elements sodium to argon. This question asks about the chemistry of each of the period 3 elements or their compounds. A. Sodium nitrate is a white crystalline solid. When heated, it melts and the following reaction occurs. So we get sodium nitrate becomes a liquid because it's being heated, and that breaks down through decomposition to sodium nitrite, which is also a liquid, and oxygen gas. A 3.40 gram sample of sodium nitrate is heated. So we have 3.40 grams. Okay, calculate the number of moles of sodium nitrate used. So moles equals mass over the relative molecular mass, which equals 3.40 grams over, so the relative molecular mass equals Na the mass of Na plus the mass of N plus the mass of 3 oxygens. 3 times oxygen, which equals the mass of sodium is 23. The mass of nitrogen is 14, and the mass of oxygen is 16. So that is 23 plus 14 plus 3 times 16. And the answer to that one is 85. 85 grams per mole. So that is 3.4 grams divided by 85 grams per mole, which equals 0.04 moles. Okay, I should have probably written it the other way around, so you had your relative molecular mass over on the left-hand side, and then you'd have more room to write your moles equals mass over molecular mass, but that's okay. It works either way, and as long as the person marking it can read it, it should be okay. So it's 0.04 moles. So the number of moles of oxygen formed. Well, the ratio of sodium nitrate to oxygen is 2 to 1. 2 moles to 1 mole. So that means if you have 0.04 moles of sodium nitrate, you will have 0.02 moles of oxygen. So it's just 0.02 moles. It's just the ratio. And calculate the volume of oxygen formed in decimeters cubed, measured at room temperature and pressure. So volume equals the moles times the molar gas volume, which equals 0.02 moles, which was just calculated, times 24 moles per decimeters cubed. Sometimes they want it formed in centimeters cubed, so you have to know how to convert between decimeters cubed and centimeters cubed. That's important. That's coming up a lot more often lately, I've noticed. All right, so the answer to that is 0.48 decimeters cubed. Okay, so the answer here is 0.48 decimeters cubed. B, magnesium reacts slowly with warm water to form a base, magnesium hydroxide. Explain what is meant by the term base. So a base is a substance that acts as a proton acceptor. So a base is a substance that acts as a proton acceptor. And remember, proton, that just means H+. An acid is a proton donor. It donates the H+, so a base can accept it. So 2, write a chemical equation for the reaction between magnesium and warm water. So we know magnesium, which is a solid, plus water, which is a liquid. I'm leaving a space in case you need to balance it. Produces, it says it produces magnesium hydroxide. So the formula for this, MgOH2. And if you forget how that's formed, the charge on Mg is it's in the second group. So this is Mg. So the charge is 2+, because it's in group 2. So it's Mg 2+, and the charge of OH is minus. So all you do is basically you swap these charges. So you have MgOH2. So the 2+ has gone down here, and the 1 has gone down here, but you don't show the 1. That's it. And so what do we have left over? Well, we have H2 gas. All right, so now that we have this, now we need to make sure it's balanced. We have 1 magnesium on the reactant side, 1 magnesium on the product side. We have hydrogen, we have 2 hydrogens here, and we have 4 hydrogens on the product side. Oxygen, we have 1 oxygen here, and we have 2 oxygens on the product side. So we have to have 2 oxygens over on the reactant side. And if you didn't know that it produced hydrogen gas, you could work out that it has to be hydrogen gas, because the only way of doing this would be to get these other 2 hydrogens, because now we have 4 hydrogens on the reactant side, and just put it as H2 gas. Okay, that's really the only way it really balances. So that's a balanced equation. C, Aluminium oxide is amphoteric. It is insoluble in water. And describe experiments to show that aluminium oxide is amphoteric. So amphoteric means it acts as an acid and it acts as a base. When you react it with an acid, it acts as a base. When you react it with a base, it reacts as if it's an acid. All right, so now we have to describe, it says describe experiments. So you have to be clear that these aren't one step. So what you want to do is you want to add some acid to the aluminium oxide, and then you want to add some alkali to the aluminium oxide. But you don't want to do it, you need to be clear that you're adding them separately. You're not taking one container with some aluminium oxide down here, adding an acid and adding an alkali. So you have to be careful that your wording makes it clear that you put them in two separate containers. You add acid to one and you add alkali to the other. Okay, you have to be clear with that. So you can say you can add hydrochloric acid to aluminium oxide and it will neutralize the acid. You could say another acid, but hydrochloric acid is very common. They want you to describe the experiments, not to say add an acid. They want you to say add hydrochloric acid or something, or another type of acid. So then you can say add NaOH or sodium hydroxide to aluminium oxide and it will neutralize the base. You could say another oxide, that's also okay. And then what do you see at the end? So aluminium oxide will dissolve into the reagent because aluminium oxide is insoluble in water, but you will see it dissolving. So you could write down aluminium oxide or Al2O3 instead of writing out the full aluminium oxide. That's okay. Just make sure you're confident that Al2O3 is the formula. If you're uncertain, just write it out in full because that's not what they're looking for. But if you get it wrong, you'll lose the mark. D. Silicon 4 oxide has a giant structure. So name the type of bonding in silicon 4 oxide. The type of bonding in this giant covalent structure is covalent. Covalent bonds or covalent. 2. Give 2 physical properties of silicon 4 oxide. Physical, not chemical. One of the properties you can say it has a high melting point. You could also say it's a poor conductor of electricity. Okay, it says only give 2 physical properties. Other things you could say if you want to put something else down, you could say it has a high boiling point. You can say it's hard. You can say it's insoluble. All of those would work, but only put down 2. E. Calcium phosphate is used in fertilizers. The bonding in calcium phosphate is ionic. Calcium phosphate contains a phosphate ion, PO4 3-. So what is ionic bonding? So ionic bonding is when we have an attractive force between oppositely charged ions. So ionic bonding is electrostatic attraction between oppositely charged ions. If you forget the word electrostatic, that's okay, but you have to have an attraction between oppositely charged ions in there. 2. Deduce the formula of calcium phosphate. So calcium, what is the charge on calcium? Ca. Calcium right here is in group 2. So that means it has a charge of 2+. 2+. Phosphate, PO4 3-, has a charge of 3-. Again, you swap the charges, so the 3 goes on calcium, the 2 goes on phosphate, and we have to put that in brackets because it's the whole thing. So the formula for this is Ca3 PO4 2. So that's the formula. F. Sulfur tetrafluoride, SF, can be made by combining gaseous sulfur with fluorine. So it's sulfur gas plus fluorine gas produces sulfur tetrafluoride. And the reaction is exothermic. It gives the energy out into the environment and then the reaction occurs. 2. Complete the energy level diagram for this reaction and include an arrow which clearly shows the energy change during the reaction. So this is an energy level diagram. All right, so what happens is in an exothermic reaction, some of the energy goes out into the environment, so the energy within the reactants has dropped. So you have to draw an arrow going exactly from the reactants line straight down. Then it's dropped to a specific level. So at that level, you draw another line here. And they have to touch. You cannot do an arrowhead on both ends. That's wrong. You are just drawing the energy change. The energy change is energy in the chemicals has gone down. And what do you have left? You no longer have sulfur gas and fluorine gas. You now have SF4 gas, which it says right in the equation up here. It says you have SF4 gas, and that's what they want. 2. During the reaction, the amount of energy given out is 780 kilojoules per mole. The FF bond energy is 160 kilojoules per mole. Use this information to determine the bond energy in kilojoules per mole of one SF bond in sulfur tetrafluoride. Okay, so we have 2 FF bonds. So we have 2 times 160 kilojoules per, what's that? So we have 2 times 160 kilojoules per mole plus, well, there's no bonds in just plain sulfur. And we have 4 times the SF bonds here. Okay, so the total energy in a reaction equals the bonds broken minus the bonds formed. The bond energy formed. The bond energy of the broken bonds and the bond energy of the formed bonds. Okay, so the total energy here, it says, is the amount of energy given out is 780 kilojoules per mole. That means the actual reaction has lost 780 kilojoules per mole. So that's minus 780 kilojoules per mole equals the bonds broken, which is 2 times 160 kilojoules per mole, minus 4 times the SF bond. So if we want to find the SF bond, SF, that equals the 2 times 160 plus 780 divided by 4, because we have the 4 SF bonds. Okay, and the answer to this is 275 kilojoules per mole. All right, so the answer here is 275 kilojoules per mole. All right. G. Chlorine and compounds of chlorine are important in water treatment and in laboratory testing for water. 1. Chlorine is added to water to make the water safe to drink. And explain why chlorine makes water safe to drink. Well, the reason why is it kills bacteria. Out of interest, it also evaporates off, so you don't drink chlorine, and so if you let it sit for a little bit of time, even after adding chlorine, you'll be fine to drink it. 2. A compound of chlorine is used in the laboratory to test for the presence of water. Name the compound of chlorine used in this test and describe the color change seen in a positive result of this test. Okay, so the chlorine compound that's used with a color change for testing for water is cobalt 2 chloride. And this is a really pretty test. It goes from a nice blue to a nice pink. So cobalt 2 chloride goes from blue to pink in the presence of water. H. Argon is an unreactive noble gas. Explain why argon is unreactive. Well, the reason why it's unreactive is it has a full outer shell containing 8 electrons. So it has a full outer shell of 8 electrons. And give one use of argon. Well, argon is used in lamps and bulbs and things like that. It is used in lamps because it won't catch on fire with a very high heat. 3. When aqueous sodium thiosulfate and dilute hydrochloric acid are mixed, a precipitate of insoluble sulfur is produced. This makes the mixture difficult to see through. So you add clear sodium thiosulfate to clear aqueous hydrochloric acid, and you get sulfur, which is a solid, which is not clear. It's a precipitate, you can't see it. And, well, it doesn't matter if with the rest you can see through or not. You just can't see through the solid. The time taken for the cross to disappear from view is measured. This is a classic clock reaction. A student adds the following volumes of aqueous sodium thiosulfate, dilute hydrochloric acid, and distilled water to the conical flask. The time taken for the formation of the precipitate of sulfur to make the cross disappear from view is recorded. So it adds a certain amount of sodium thiosulfate, a certain volume of hydrochloric acid, and a certain volume of distilled water. If you notice, 40 plus 10 plus 10, that's 60. 30 plus 10 plus 20 is 60. So these all have to add up to 60. A. State the order in which the aqueous sodium thiosulfate, hydrochloric acid, and distilled water should be added to the flask. So in order for the reaction to happen, you have to have the hydrochloric acid react with the sodium thiosulfate, which means you want to make sure that one of those is added at the very end. You do not want to add water at the very end. The order I would say in would be to first of all add water. Secondly, I would say to add the hydrochloric acid. And thirdly, I would say finally to add sodium thiosulfate. But there's actually a few other options. As long as either hydrochloric acid or sodium thiosulfate is at the end, that would work. You could also, these are other options, only put down one option. You could say to put water and then Na2S2O3, sodium thiosulfate, and then hydrochloric acid. That's absolutely fine. Another thing you could do, you could add Na2S2O3, sodium thiosulfate, then you could add water, and then you could add hydrochloric acid, because the reaction starts when hydrochloric acid and sodium thiosulfate touch. The other thing you could do, which I would actually say would count as a wrong answer, but it's not, it's counted as a right answer. You could add hydrochloric acid, and then you could add water, and then you could add Na2S2O3. The reason I'd say this is because you always add your acid to your water. This is a safety thing. So I'm surprised that they accept this as an answer, but it would make the reaction work. It just wouldn't be as safe as the other options. B. In experiment 3, the student wanted the sodium thiosulfate to be double the concentration used in experiment 2. 1. Complete the table to show the volumes which would be used and the expected time taken for the cross to disappear from view in experiment 3. I'm sure you figured out that this question was coming because they wouldn't just leave a blank spot on a graph, on a table. So what you do here, as we said, each one of these, all these volumes put together equals 60 centimeters cubed. So if they want the sodium thiosulfate volume to double, obviously that has to be 40. Then this one has to stay exactly the same. That's 10 in both of those, so it's probably going to stay the same there. So 40 plus 10 is 50. Well, obviously this one has to be 10. If you double the concentration of the reactant, but keep the other reactant the same, well, then you're going to have how long it takes for the reaction to happen. So 28 seconds will go to 14 seconds. That's it. 2. Use collision theory to explain why increasing the concentration of sodium thiosulfate would change the rate of reaction. So basically, if you have more particles in a particular space for the higher concentration, it will increase the rate of the collisions occurring. So there are more particles per unit volume in the higher concentrations, and this increases the rate of the collisions. C. The student repeated experiment 1 at a higher temperature. Use collision theory to explain why the rate of reaction would increase. Well, it would increase because the particles have more energy and they move faster when they're at higher temperatures. What this means is that it increases the rate of the collisions again, and there's a higher proportion of the collisions that have enough energy to react, that have enough activation energy for the reaction. So particles have more energy and move faster when they're at higher temperatures. This increases the rate of the collisions, and a higher proportion of particles have enough energy to react. It's the rate of the collisions and the higher proportion of energies have their activation energy for the reaction. Those two things together are important as well. You can't just say more collisions. You can't just say they have enough energy. You have to say the rate of the collisions has increased, and more of the particles have enough energy to reach their activation energy. Question 4. Electroplating steel objects with silver involves a 3-step process. Step 1. A coating of copper is applied to the object. Step 2. A coating of nickel is applied to the object. And step 3. The coating of silver is applied to the object. So it goes copper, then nickel, then silver. A diagram of the apparatus used for step 1 is shown. So we have the copper anode, and the steel cathode. All right. Whenever I see an electrolysis question, I always start off by saying panic. The only time you should panic on a science exam. Positive, anode, negative is cathode. It's not always useful, but it often is. Okay. So we have the copper at the anode, the steel cathode, and our electrolyte is aqueous copper 2 sulfate. 1. The chemical process taking place on the surface of the object is, we have our copper 2 plus ions, which are aqueous, plus 2 electrons produces a solid copper. So that forms on top of the star here. Explain whether this process is oxidation or reduction. Explain means don't just state. Don't just say it's oxidation or reduction, you have to say why. So this is reduction. And I always remember this from what my teacher taught me when I was really young in high school. It was Leo, the lion says grr. A lot of other people remember it as oil rig, but I like Leo, the lion says grr. Okay, loss of electrons is oxidation, gain of electrons is reduction. So this copper has gained electrons, or reduction is gain, same thing. Okay, so reduction, because that's what explaining is. It wants a because. The copper ions are gaining electrons. There we go. Reduction because the copper 2 plus ions are gaining electrons. 2. Explain why the concentration of copper ions in the electrolyte remains constant throughout step 1. Well, if you look at this, so copper sulfate is blue. So some of this blue because of the copper ions. Some of the copper will be going here, and it will be replaced copper from the anode. So what's coming from the anode will go onto the cathode, and the same amount will stay in the solution. So the copper ions are formed at the same rate that they're being removed. So Cu2 plus ions are formed at the anode at the same rate as Cu2 plus ions are removed at the cathode. B. Give 2 changes which would be needed in order to coat nickel onto the object in step 2. Well, first of all, you need to change the anode from being copper to being nickel. So the copper anode would have to be replaced by nickel. And the other thing is, you have to change the copper sulfate electrolyte to being nickel sulfate. So the electrolyte would have to be nickel 2 sulfate. It could be another nickel salt as well. So nickel 2 sulfate is a good one. C. Copper, nickel, and silver are transition elements. Typical physical properties of transition elements are a high density and a high melting point. Give 3 different properties of transition metals which are not typical of other metals. So things that make transition elements unique. Well, one of them is that they are good catalysts. So generally they're very good catalysts. The reason why they're good catalysts is because they have variable oxidation states. So they have variable oxidation states. And the other thing about transition metals is that they're generally nice, pretty colors. So they form colored compounds. All right, that's the end of question 4. Question 5. Sulfuric acid is produced by the contact process. The steps of the contact process are shown. So we have our starting material. The step 1, it turns it into sulfur dioxide. Step 2, sulfur trioxide. Step 3, it becomes oleum. And step 4, sulfuric acid. A. Sulfur is a common starting material for the contact process. Name a source of sulfur. And sulfur is often found as an impurity in fossil fuels. So they can be found in sulfur-containing fossil fuels. B. Describes step 2, giving reaction conditions and a chemical equation. Reference to reaction rate and yield is not required. Okay, step 2, it goes from sulfur dioxide to sulfur trioxide. For this reaction to occur, it needs a catalyst, specifically a vanadium pentoxide catalyst. So it uses a vanadium pentoxide catalyst. Other ways of writing vanadium pentoxide, we have vanadium 5 oxide, or we have V2O5. You can write down any of those. Okay, so it uses a vanadium pentoxide catalyst, and the pressure is 1 to 5 atmospheres. So it's done at a pressure of 1 to 5 atmospheres. It needs a temperature of 450 degrees Celsius. So it needs a temperature of 450 degrees Celsius. The reaction, that's another thing that is important in this, it needs a chemical equation. The chemical equation for this is, it's a SO2 plus oxygen produces SO3. Obviously that's not balanced. We have 1S, 1S. We have 4 oxygens and 3 oxygens. So the way to balance this is we put 2 sulfurs, because we obviously have to put 2 on the right hand side, and to do that we can balance it by putting 2 in front of the sulfur dioxide. Okay, and this reaction, it's a reversible reaction. It's at equilibrium. So you could have written this equation with the reversible reaction arrows. All right. C, step 3 involves adding sulfur trioxide to concentrated sulfuric acid to form oleum. Complete the chemical equation for this reaction. All right, so you might know the formula of oleum or you might not. But we could just basically put this together. So first of all, we start with the H's. Let's say H2. And how many S's do we have? We have 2 S's. S2. How many oxygens do we have? O7. There you go. That's it. D, dilute sulfuric acid is a typical acid. A student adds excess dilute sulfuric acid to a sample of copper 2 carbonate in a test tube. 1. Give 3 observations the student would make. All right, so we have, just to write down the equation, you don't need to do this. It's not saying this is important. Just to write down the formula, we have H2SO4, that's dilute sulfuric acid, plus, so it's aqueous, plus solid copper 2 carbonate, CuCO3, that's a solid, and that gives you, well, we know an acid plus the copper carbonate, acid plus a carbonate produces CO2, that's a gas, and water, that's a liquid, and we have the copper and the sulfate go together, so basically it swaps, CuSO4. And if you look at this, it's actually balanced. But you don't need the equation, so it doesn't matter if it's balanced. So give 3 observations a student would make. Well, first of all, the copper carbonate is dissolving in it, in the acid. So you would get Cu2 plus ions forming. And those Cu2 plus ions are blue. Another thing you would see is a gas being produced, and that is often called effervescence. I like that word, it's a good word, but you could say bubbles or fizzing as well. And finally, the other thing you would see, you'd be putting in it, we'd probably put this at the beginning if you wanted, you'd put in a solid, and we have gas, liquid, and this is finally here is aqueous, it dissolves. So the solid dissolves into the solution. It says give 3 observations, you need all 3 of those, even though it's for 2 marks. 2, give the names of all the products formed. Well, if you've written out the equation, you can find the names. If you haven't, you have to figure it out. Okay, so we have carbon dioxide. We have water. And we have copper 2 sulfate. Now it says the names. It means they do not want the symbols. That's what they want. They want the names. E, concentrated sulfuric acid has different properties to dilute sulfuric acid. When concentrated sulfuric acid is added to glucose, C6H12O6, steam is given off and a black solid is formed. Name the black solid. So, if you look at this, C6H12O6, steam is given off, so that's H2O. Now, how many H2Os can you get out of this? Well, you can get 6 H2Os out of this. So 6 times 2, that's 12, plus 6 oxygens, 6 waters come out of this. What you're left behind? You're just plain carbon, which is a black solid. So what type of reaction has occurred? Well, it's losing water. This is called a dehydration reaction. There we go. Question 6. Petroleum is a source of many important chemicals. A. Name 2 industrial processes which must take place to produce alkenes from petroleum. Okay, petroleum is a mixture of different molecules, so you have to do fractional distillation. And then you break off the parts that you want so you can get an alkene, and that's called cracking. Catalytic cracking. Cracking. B. Ethene, CH2CH2, and propene, CH2CH3, can both be converted into polymers. What type of polymerization takes place when ethene forms a polymer? Basically, it's creating a polymer around a double bond. That is addition. So it's addition. What is the empirical formula of the polymer formed from ethene? Remember, empirical formula means the most simple formula. Okay, so the molecular formula for ethene is C2H4. If you were to make that the simplest form you possibly can, you would divide each number of these by 2. So that's just CH2. 3. Propene has the structural formula CH2CHCH3. Draw 2 repeat units of the polymer made from propene. So if it goes over the double bond, that means that 2 repeat units actually only has 4 carbons in a row. Okay, and off of each one of these, we have a CH3. Okay, this doesn't say draw all of the atoms and all of the bonds. If it did, you'd have to do the CH3 like this. It didn't, so you can write CH3. But feel free to write it so that you show all the bonds. It doesn't say you shouldn't do it. All right, and so off of each of these, we have 2 hydrogens. Well, 1 hydrogen off of those ones. So we have hydrogen, 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 and this is saying that it's just repeating. This says 2 repeat units. That's repeat units, which means you don't draw the little square brackets with an N around it. If the question had asked for a monomer, you would draw it so you have the same sort of thing. You'd only draw 1 molecule. You'd say C, to the long line there. We'd do an H, 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 CH3, and then you would do the square brackets around it with the N. That's drawing a monomer. Okay, this is the repeat units. So you're breaking the double bond, and whatever else is off of that double bond, it doesn't matter. You just put it as another bond. The new monomer is being added to the other side of the double bond. C. Ethene will react with steam to form ethanol. Propene will react with steam to form 2 isomers, both of which are alcohols, and suggests the structures of these alcohols. So if we look at the ethene reaction, this is not what they ask you to write down, but this is the ethene. I say monkeys eat peeled bananas. So ethene, it has 2 carbons. Although it told you that up above, but if you don't remember it, that's how you do it. All right, so we have ethene. We have C, double bond C, H, 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 H. It reacts with steam to form an ethanol. So what it does here is it reacts with water, H2O, to form an ethanol, C, C, H, 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 OH. All right, so that's all it's doing. So each carbon already had 2 hydrogens on. 1 hydrogen went here, and 1 OH went here, and that's where the water went. So it turns from an alkene into an alkane. So the question, so this is not what it wants to show you. It doesn't want you to show you. It doesn't want you to see that. That's not the answer. The answer, if we start off with propene, we have C, C, double bond C. Monkeys eat peeled propene, so 3 carbons. And we have H, H, 1H, and then HH. Doesn't matter if this H is on the top or the bottom, it doesn't matter. Now the alcohol, so the double bond is broken if it reacts with H2O, and the alcohol can either add here or here. And wherever it doesn't add, the hydrogen is added. So it wants you to draw two structures, two isomers. So we have both of them have 3 carbons in a row. All right, one of them can have an OH on the last carbon or the first carbon. It's exactly the same if you put on the last carbon or the first carbon. And one of them can have the OH on the second carbon. All right, it doesn't matter which one's which. You could put, and this last one, you could put it on, you could put it here or you could put it here. It doesn't matter. This hydroxide you could put underneath as well. It doesn't matter. Okay, and all the other ones, so that there's 4 bonds on every carbon, you need an H. Again, it does not say draw all of the atoms and all of the bonds. If it said draw all of the bonds, you would have to draw a line in between the O and the H. It doesn't say that, so you don't need to. All right, so that is the answer to that one. D. Esters are organic chemicals noted for their characteristic smells. Ethanoic acid and methanol will react to form an ester. Name the catalyst needed to form an ester from ethanoic acid and methanol. Well, the catalyst you use is concentrated sulfuric acid. So concentrated sulfuric acid is needed. 2. Name the ester formed with ethanoic acid when ethanoic acid reacts with methanol. Well, you write the alcohol first, and then you write the acid. So this is called methyl ethanoate. Okay. And 3, draw the structure of the ester formed when ethanoic acid reacts with methanol and show all of the bonds. So this time it does say to show all of the bonds. So what we have to do here is we starts with methyl. So it starts with methanol. So the structure of methanol is, you don't draw what the starting reactants. This is just me showing it to make it clear. So methanol, OH, that's methanol. H, 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 plus ethanoic acid. So I'm going to do it the other way around. C, C, O, OH. And these are H's. All right. So when methanol reacts with ethanoic acid, one H from one of the molecules and one OH from the other molecule, doesn't matter which one gets which, it results in the same thing. These come off as water, and so there's the oxygen joins between the carbon. So this is not what you're supposed to draw. You're supposed to draw the C, O, C, C. Always draw the backbone first. It makes it easier. So this is the backbone, C, O, C, C. And then you can add the things that come off of it. So we have an H, H, H off of the first one. We have a double bond O off the second one. And that's already 4 bonds on there, so don't draw another H. And we have H, H, H. There we go. That's it. That's all it asks for. Oh, don't draw this. So this is all that's being asked for. 4. Give the name of a polyester, and a polyester you should know is called terylene. All right, and that is the end of this chemistry exam. I hope you have found this useful. If you have, I'd really appreciate if you'd press the like button and you'd subscribe if you haven't already. And if you have any questions, any comments, anything you'd like to say to us, then please write them in the discussion section below. We really like to hear from you. And have a great day.